This lecture video is on applications for quadratic functions, and we're going to be looking at the maximum and minimum for a quadratic function. So remember, the quadratic function or parabolas either open down like this if a is negative, so if a is less than 0, and then we would have this very top point called the vertex, which would be our maximum. Or if a is positive, then the parabola opens up, or the quadratic function opens up, and we would have a vertex down here on the bottom, and that would be a minimum then. Okay, and so that's when a is greater than 0. So we're going to take a look at some application problems that use that information. Our first example here, if a projectile is fired straight upward from the ground with an initial speed of 96 feet per second, then its height h in feet after t seconds is given by the equation h of t equals negative 16t squared plus 96t. We want to find the maximum height of the projectile. So here's the equation of our quadratic function or our parabola, and this number t squared is number in front of t squared, or a, is negative 16, and so our parabola does in fact open down, and so we do have a maximum point up here at the vertex. So that's what we need to do, is find our vertex. And so the x value of our vertex, remember, was at negative b over 2a. So we have a negative sign out in front, that's this negative sign. And then on the top, we want b, and b for this one is 96. It's always the number in front of the variable that's not squared. So 96, and then over 2 times a, and a for this parabola is negative 16. Okay, so now let's do that calculation. So we have negative 96 over negative 32. And a negative divided by a negative is going to give us a positive number, and that is positive 3, if I have my calculations correct. 96 divided by 32 and that is in fact 3. So the x-coordinate of our vertex is at 3, so x is after t seconds. So this is seconds. Whoops, I don't need an equal sign there. And we need to find the height of this projectile. And h of t, or y, is our height for this one. So we need to find the value h of t. So that would be putting this 3 into our height function. So negative 16 times 3 squared plus 96 times 3. So 3 squared is 9, and 9 times 16 gives us 144, so that's negative 144, plus 96 times 3 gives us 288. Oh, I forgot a 4. 144 plus 288, and so we get positive 144. And this is in feet. So write a sentence to answer this. The maximum height of the projectile is 144 feet. Okay. Our next example here, the Utah Ski Club sells calendars to raise money. The profit P in cents from selling X calendars is given by the equation P of X equals 360x minus x squared. So A again for this one is negative 1. So we have that's opening down like this, and we have a maximum at our vertex. So how many calendars must be sold to maximize profit? So the number of calendars is x, so we need to find the x coordinate of our vertex, and that's at negative b over 2a. And here's our equation for our quadratic function or our parabola. So b, remember, is always the number in front of the variable that's not being squared, so that's this 360 here. And then divided by 2 times a, and a is always the number in front of x squared. And since there's no number there, it's a negative 1. And so 360 divided by 2 is 180. So the Utah Ski Club must sell 180 calendars to maximize profit. Okay, the next part of this is to find the maximum profit. So to calculate the maximum profit, we're going to use our profit function, and we're going to put in the amount of calendars that they have to sell in order to achieve that maximum profit. So we want to find P of 180. That's 360 times 180 minus 180 squared. All right, so what do we get here? 360 times 180 gives us 64,800 minus 180 squared. That gives us 32,400. And so when we subtract, we get 32,400. Okay, so be careful about this because the profit in this equation is in cents. So this is 32,400 cents. So if we want to convert this to dollars, there are 100 cents in each dollar. Okay, so we have cents. If we want to convert this into dollars, we would put the $1 on the top. And put the 100 cents on the bottom. Okay, so we would have to divide this 32,400 by 100, and that would give us 324. So the maximum profit is $324. And one more application problem here. The length and width of a rectangle must have a sum of 50. Find the dimensions of the rectangle that will have the maximum area. So here's my rectangle. And the length, so if I call this the length and this the width, or you can do it the other way around, doesn't matter, but they have to add up to give me 50. And what we want to do is we want to have a maximum area, so we need to write an equation for area here. And area is length times width, and we don't want two variables in our area equation, we only want one. So we can solve this for one of the variables. You can pick, I like to have my functions written in terms of x, so so I'll figure out what this y is in terms of x. So I want to solve this for y. So subtract x from both sides, and I get y is equal to 50 minus x. Okay, so then the area of this in terms of x would be x times 50 minus x. And if we distribute this x, we get 50x minus x squared. So this is a parabola that opens down, so there is some maximum value, and we want to figure out what that is. So the maximum is going to occur at the vertex, and the x-coordinate of the vertex is at negative b over 2a. And b for this parabola is 50, and a for this parabola is negative 1. So we would get negative 50 over 2 times negative 1, which is positive 25. And so x is one side of this parabola, and we know that the sum of the two sides has to give us 50, and so you can actually just plug it in right here. So this is 50, and not 50, sorry, 25. That was what we got. And so then you can just replace this x with what it is, which is 25, and so we would get y is also equal to 25. And so the dimensions of the rectangle that will have a maximum area are 25 and 25. And there aren't any units on that, so we don't need any units there. And this is always the case. A rectangle that has maximum area is always a square, and some people try to get me on technicality here, but technically a square is a rectangle. It's a special rectangle that have all sides the same length. So square really is a rectangle in geometry. That's it for this lecture video, so let me know if you have any questions. Thank you.